Hello students, welcome to my channel Maths Hub. So in my last few videos I'm talking about graphs and today I'll talk about isomorphic graphs. So let's come to the definition of isomorphic graphs. When can be two graphs called isomorphic? So isomorphic is basically a carbon copy, so a mirror image of each other. So we say that two graphs G and H are said to be isomorphic to each other if there exists a one-to-one correspondence between the vertex set as well as the edges. So one-to-one correspondence means that we are able to define a function from the graph G to the graph H so that the vertex and the edges, they are all preserved, right? Now, what do we mean by preserved? So for one-to-one correspondence, we need to check that both the graphs should have the same number of vertices. It should have the same number of edges. The degrees of all the vertices in graph G should be equal to the degrees of all the vertices in the graph H. And the last point is the spatial arrangement should be different, right? That means only the spatial arrangement means the way G represents from H, they should differ, but you can say that it should be a carbon copy of each other, right? So let's see how to check whether two graphs are isomorphic or not. So here are two examples. You are given graph G and graph H. So you can see that in graph G, we have the vertices V1, V2, V3, V4 and V5. And in graph H, we have the vertices U1, U2, U3, U4 and U5. Right? Now, how to define a one-to-one correspondence or how to define a mapping from graph G to graph H? So first of all, let us see that in graph G, if I talk about graph G, there are five vertices, sorry, V1, V2, V3, V4 and V5, right? So now let's see what are the degrees of these vertices. V1 has degree 4 and you can see that V2, V3, V4 and V5, they all have degree 3. Now let's talk about graph H. How many vertices do graph H have? We have U1, U2, U3, U4 and U5. So you can see that the U1 vertex has degree 4 and rest U2 has degree 3, U3 has degree 3, U4 has degree 3 and U5 also has degree 3, right? So can we say that it has same number of vertices and the degrees of the vertices are also same? Now let's count the number of edges. The number of edges in graph G are how many? It is 1, 2, 3, 4, 5, 6, 7, 8. 8 edges in graph G. Now how many edges are in graph H? Graph H has how many edges? 1, 2, 3, 4, 5, 6, 7, 8. 8 edges in graph H. So vertices are same, edges are same, the degrees are same, right? Now how will I define a mapping F from G to H? How will I define it? We will say, how will I mark it? I have to mark that vertex to that vertex in graph H so that their degree should match each other, right? So I will define a mapping F from G to H such that, how is it defined? F of V1, the first vertex V1, it has degree 4. So it will be mapped to a vertex of degree H which also has the same degree. So it will be mapped to U1 vertex, right? Now rest of the vertices have the same degree. So you can map F of V2 to U2, F of V3 to U3, F of V4 to U4 and F of V5 to U5, right? So this is how you will define the maps and hence we can say that graph G and H, they are isomorphic to each other, right? G and H are isomorphic to each other. So you can see that the arrangement of the vertices and the edges are different. So the spatial arrangement is different, but the rest of the things, they are exactly the same, right? So in this example, graph G and graph H are isomorphic to each. Now let's see some more examples. Let's talk about the next exercise. We need to check whether these graphs are isomorphic or not. So let us mark the first graph, which is marked as figure 1. Let us mark this as graph G. And let us mark the figure 2 by graph H. Right? So we'll list down graph G and we will list down graph H. So if I talk about graph G, it has vertex A, B, C, D and E. And if I talk about vertex of H graph, it has P, Q, X, Y and Z. Right? So now that means 5 vertices here, 5 vertices here. Let's count the edges now. How many edges it has? 1, 2, 3, 4, 5, 6, 7. 7 edges here. How many edges in H? 1, 2, 3, 4, 5, 6 and 7. Right? Now, let's come to the vertex set now. The vertex we have already written. Let's count their degrees. So, degree of vertex A is 4. Degree of vertex B is 2. Degree of vertex C is 3. Degree of vertex D is 3. Degree of vertex E is 2. That means there is one vertex with degree 4, 2 vertices with degree 3 and 2 vertices with degree 2. Now let's talk about P vertex. P has degree 3, Q has degree 3, X has degree 2, Y has degree 3, Z has degree 3. So can these two graphs be isomorphic? You can see that the degrees are different, right? So since the degrees of the vertices are different, so we cannot define a mapping F from G to H such that G is isomorphic to H. This is not isomorphic to H, right? So the answer to this problem will be that it is not an isomorphic graph. And what is the reason behind it? The reason is that G and H, they do not have the same degrees with the vertices, right? Let's hear some other exercises. So we need to check whether these two vertices, these two graphs they are isomorphic or not. So again, let's mark this with graph G. And let's mark the second graph with the symbol H. So now let's talk about G and H separately. So G has the vertices A, B, C, D and E. And H graph has the vertices A, B, C, D and E. So it has the same edge vertices, right? How many edges it has? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 edges in both the graphs. Now let's talk about the degrees. Degree of vertex A is 2. Degree of vertex B is 3. Degree of vertex C is 2. Degree of vertex D is 3. Degree of vertex E is 2. Now let's talk about graph H. Degree of vertex A is 3. Degree of vertex B is 2. Degree of vertex C is 3. Degree of vertex D is 2. Degree of vertex E is 2. Right? So can we match the degrees now? There are 3 vertices with degree 2. Same here. 3 vertices with degree 2. And we have 2 vertices with degree 3. So we have 2 vertices with degree 3. So it is exactly the same. So can we define a map F from G to H? Yes, we can define this map such that how will the vertices be mapped? F of A A is a vertex which has degree 2. So you can map this vertex to another vertex in graph H which also has degree 2, right? So you can see that we are defining the function as f of A is equal to B. So I have mapped A with B. Similarly, let's see where will B go from G. B has a vertex with degree 3. So we can map B with A, right? Similarly, f of C is equal to C is a vertex with degree 2. So I can check out D here. So f of C is equal to D. Then f of D is a vertex with degree 3. So I can choose a vertex here. So that is C. And then I can write f of E goes to E. E is left out here. So E goes to E. And hence I can say that G is isomorphic to H. Definitely isomorphic to H. Right? So I hope it is clear. Okay. So now let's move on to the next exercise. So you need to tell me whether these two graphs are isomorphic to each other or not. Right? So now let's again mark this with G. And now let me mark this with G dash. So G has the vertices A, B, C, D and E. And G dash also has the vertices A, B, C, D and E. Right? Now, how many edges G has? 1, 2, 3, 4, 5, 6. And how many edges G dash has? 1, 2, 3, 4, 5, 6. So 6 edges in both. Now let's come to their degrees. Degree of vertex A is 2. Degree of vertex B is 3. Degree of vertex C is 2. Degree of vertex D is 3. Degree of vertex E is 2. Now let's talk about vertex A in G dash. It has degree 3. B has degree 3. C has degree 3. D has degree 1. E has degree. So can we say that G and G dash are isomorphic? Now if you check the degree sequence, you have 3 vertices with degree 2 and 2 vertices with degree 3 in G. But if you check in G dash, there are 3 vertices whose degrees are 3. There is one vertex whose degree is 1. And there is one vertex whose degree is 2. So the degree sequence is not same. And hence we can say that G is not isomorphic to G dash. Right? So now I leave another question and I give this question as an exercise to you. So you are given two graphs. So let me name this for you. This has G and this has G dash. And you need to comment me in the comment section whether G is isomorphic to G dash or G is not isomorphic to G dash. You need to tell me which one will satisfy it, right? So do attempt the question and do let me know in the comment section, right? So that's all with the isomorphic graphs. So thank you so much for listening to me and do subscribe my channel. Believe in yourself and you will be able to succeed. Thank you so much.